Here's a brief review on how to find the asymptotes of your function. So there are two kinds of asymptotes, vertical and horizontal. You'll recall this equation from our earlier review lesson, and you'll remember that the restriction on the x value is x cannot equal 1. So to find your vertical asymptotes, you have to check the limit as x approaches 1 from the left and from the right. First, let's check the limit as x approaches 1 from the left. We set this equal to 1 over 1.5. We can just take it from here. We set this equal to 1 over 0.99, a value slightly to the left of 1, minus 1. This is equal to 1 over negative 0.01. So, because this value can be assumed as being ever changing, ever smaller, we say that this limit, as x approaches 1 from the left, is equal to negative infinity. Because the limit approaching our restriction from the left and the right are approaching negative infinity and infinity, we can say that there is a vertical asymptote at x equals 1, which is our restriction. Next, we have to check for horizontal asymptotes. So, we take the limit of f of x as x approaches infinity, which would be equal to 1 over infinity minus 1, or 1 over infinity. Now, we say that any number divided by infinity is equal to 0. Therefore, the limit of f of x as x approaches infinity is 0. That means that we have a horizontal asymptote as x approaches infinity. However, we must also check it as x approaches negative infinity. I'm just going to write it out. Maybe we'll just cut it in the middle. Our final step is to check the limit of f of x as x approaches negative infinity. We follow the same steps as before, plugging in negative infinity for our x. This will simplify to 1 over negative. This will simplify to negative 1 over infinity, which once again we say is equal to 0. Therefore, this equation has a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 0.